Hi, today we are solving quadratic equations by factoring. So, I don't know what method you've been taught to factor. In our class, we kind of do an X method, where the last number is a number where we put on the top of the X. We're going to look for two numbers that are going to multiply to give us that one. And we're going to look for two numbers, in this case, that are going to add to give us negative 10. So we'll have two numbers that are going to multiply to give us a positive 16, add to give us negative 10. Hopefully we'd come up with negative 8 and negative 2. So that means you would end up with x minus 8 in one set of parentheses and x minus 2 in the other set of parentheses. And that would complete the factoring part of this problem. Now, I don't know if you know the zero product rule, but if you have two terms, they're being multiplied together, and you want them to equal 0, that means either A is going to have to equal 0, or B is going to have to equal 0. Since both sets of parentheses represent a term, we can set both of them equal to 0 to get our answers. So we take the x minus 8 and set that equal to 0. We take the x minus 2 and set that equal to 0. Going through basic solving techniques, we add 8 to both sides for the first equation and get x equals 8. In the second case, we add the 2 to both sides, and we get x equals 2 for the answer. If we check out the second problem on the notes, in this case, we're going to look for two numbers that are going to multiply to give us negative 56 and add to give us a positive 1. In this case, hopefully you come up with 8 and negative 7. So the parentheses will be b plus 8 and b minus 7. Once again, we then set each part individually equal to 0 to come up with our answers. So in the first case, we'll subtract the 8 and get negative 8. Second case, we're going to add the 7. And we'll get b equals 7. Now, in the third case, notice it is different than the previous two because this one does not equal 0 yet. So your first move is to make it equal 0. To do this, in this case, we're probably going to want to subtract the k from both sides. I highly recommend you put this in standard form, meaning that the k is going to go between the k squared and the negative 12. Once you've completed that, this is now the same as the last type of problems. So we're going to look for two numbers that are going to multiply to give us negative 12, and in this case, add to give us a negative 1. Hopefully we'll come up with negative 4 and 3. So our parentheses will be k minus 4 and k plus 3. Once again, we set them equal to 0. And solve. So for this problem, our answers are k equals 4 and k equals negative 3. Now for number 4, once again, we need to get this equal to 0. Now if you notice when we looked at the other ones, the leading coefficient on the squared term was always a positive 1. So in this case, I would recommend that we subtract the 5n and subtract the 24 from both sides. So that the n squared remains positive. So here we're going to look for two numbers that are going to multiply to give us negative 24 and add to give us negative 5. Hopefully you come up with negative 8 and 3. We'll put n minus 8 in the one set of parentheses, n plus 3 in the other. To finish it off, we set them both equal to 0 and solve. Some people may be noticing basically all you got to do is switch the signs on the parentheses. That is correct. And that will get you to your answer a little bit faster, although you got to be careful about this, as you will see in the next couple problems. So for this one, you will see that the answer is n equals 8 and n equals negative 3. Now, in this case, we're down to 2 terms. However, notice both terms have a variable in them. So I don't know if you're used to factoring out a greatest common factor, but that's what we're going to do. And in this case, the greatest common factor is the x that's in both terms. So we're going to divide both terms by the x. So the x we divide out goes in front, then we start our parentheses, and then we simplify the fraction. So the 5x squared over x should simplify to give us a 5x. The 8x over x would simplify to give us 8. So the factored terms in this case will be x, and then the 5x minus 8. Just like the other ones, we're going to set them equal to 0. Notice right off the bat, one of our answers are going to be x equals 0. As far as the other one, we're doing our normal solving, 2-step equations. So we add 8 to both sides. We divide by the 5. And we see that in this case, the second answer is going to be 8/5. The last problem, probably the toughest one here. It's because we have a leading coefficient here. That means for our x method, we need to multiply the 7 and the 10 to get 70. So we're going to be looking for two numbers that are going to multiply to give us 70. And we're going to still add to get negative 19. At this point, hopefully you came up with negative 14 and negative 5. I don't know if you're used to factoring using this method, but then what we do in this case is the 7a squared and the plus 10 remain. The negative 19a gets replaced by the minus 14a and the minus 5a. So we're using the two numbers we got from our x in the middle here. Notice if we add them back up, the negative 14 and the negative 5 would give us the negative 19 that we started with. At this point, now that we got 4 terms, we're going to do the factoring by grouping, so we're going to pair them off. Out of the first pair, we're going to factor out a 7a. When we do the division here, we should end up with a into minus 2. Out of the second pair, we want to take out a negative 5. Once again, we will be left with a minus 2 in the parentheses. So the two parts that were taken out go in one set of parentheses. And then technically what we've done is we factored out the a minus 2, so it gets listed once. Now that we've done this, set each one equal to 0 and solve. So on the left we'll have the 5 first. divide by the 7. So one answer will be 5/7 for A. And for the equation on the right, we'll add the 2 to both sides. And we'll get A equals 2. So I hope this helps as we were solving quadratic equations by factoring.